Hello, my name is Jing, and I'm delighted to share our work FabTouch, a tool to enable communication and design of tactile and affective fabric experiences with you today. I had the pleasure of co-authoring this study with Bruna Petreca from Royal College of Art, Christopher Dawes, and Professor Marianna Obrist from Multisensory Device Group at the University College London. So when we're interacting with fabric products, whether it's choosing a cozy blanket at a store or picking out an outfit for the day, we use all of our senses without even realizing it. We touch, hear, and feel the fabrics as we're selecting them. However, with the rise of digital experiences such as online shopping, we are missing out on these experiences. So developing interactive digital experiences for fabric present a challenge, mainly because there are currently lack of tools for communicating the tactile and affective experiences of fabrics between designers, users, and developers. In this paper, we sought to examine users' tactile and affective experiences through a mixed method approach. We asked questions such as, what are users' tactile experiences when they touch a fabric? What are users' affective experiences when they touch a fabric? Can we create a tool that can facilitate the communication of fabric experiences for the design and technology development process? To answer these questions, we ran our study focused on cotton materials because it is one of the most commonly used materials, and it is accounting for 35% of the world's fabric consumption. We select 9 cotton fabrics for our study. They are heavy jewels, buckram, flannel, organza, velvet, voile, calico, muslin, and tow. We choose them because they offer a variety of textures. Our approach involves using microphonological interview technique with questionnaires to capture both qualitative and quantitative data. The questionnaires ask participants to rate their tactile perceptions of each fabrics and their affective responses using the self-assessment mannequin scale. Our qualitative data was collected through the microphonological interview technique, which focuses on the structure of the experiences, aiming at eliciting verbalizations of subjective experiences and exploring the development and specific configuration of experiences at a particular time. In a typical MPI interview, we tend to ask how and what question to unfold the user's temporal experiences. The questions are designed to guide participants in reflecting on their experiences over time, or in the other word, the diachronic structure, as well as to encourage them to explore the sensory, emotional, and cognitive dimensions of their experiences. The study was set up where the participants could only explore the fabrics through touch. 9 cotton samples were mounted on an A3 white card and placed inside a white box with a curtain in front to prevent the participants from seeing the fabric. The study was divided into 3 parts: formalization, interviews, and questionnaire. We ran the study with 27 participants aged between 18 and 45. The collected data was transcribed and analyzed using qualitative data analysis software and Vivo. From the transcribed data, 2,945 expressions were identified. The participants were most likely to express fabric assessment, 34%, and for fabric properties, 24% of the expressions. In contrast, only 3% of the expressions are related to preferences. All the collected data were then classified into 6 overarching diachronic structures, D1 to D6, and 23 synchronic structures, S1 to S23, in order to provide an overview of the temporal fabric tactile experiences. Our results suggest that the participants often started by expressing the fabric assessment and properties, then start to describe their association with past experiences. Afterwards, participants tend to express their sensory responses before they move on to their emotional responses. Lastly, they will talk about their preferences, which were mainly related to touch and material. We analyzed the detail of our synchronic structures regarding to each of the 6 diachronic structures and their correlation to each fabric samples. From the data, there are more hand movement was described during the participants expressing their fabric assessments, and a great tendency of describing the surface properties when participants expressing fabric properties. We analyzed, in addition, for fabric associations, participants tend to associate with object more when they touch the fabric. Regarding sensory responses, participants tend to describe the position of the sensation on their hand more than the others. The emotional responses of fabric, especially for more soft materials such as velvet and flannel, are more likely to generate pleasant rather than unpleasant and neutral feelings. Although not many expressions regarding the preferences, there is a tendency that participants express touch preferences more than material preferences. We compared our qualitative results with analyzed questionnaires. For example, for the thumb questionnaire, we use a linear mixed effect model to investigate the effect of different fabrics on participants' valence, arousal, and dominance ratings. Our results show that valence ratings are significantly different between fabrics, with velvet being rated higher in valence than all other fabrics. Arousal ratings are also different between fabrics, with buckram being rated higher than others. However, no significant differences in dominance ratings were found. These quantitative findings were consistent with the qualitative data we obtained from the interviews. Based on these findings, we developed the tool FabTouch, which is a physical representation of fabric temporal, tactile, and affective experiences that can be used by designer, researcher, or consumers to explore and communicate their fabric experiences. The tool opens like an accordion book and is organized in a diachronic and synchronic structures, allowing users to explore their tactile and affective experiences over time. The FabTouch tool we developed is designed to capture the richness and complexity of fabric tactile and affective experiences we identified in our study. Our initial consultation with designers from different fields suggests that FabTouch can be used as an educational tool by fashion and textile students to learn users' fabric experiences and to incorporate those insights into the design. Also, the FabTouch tool has the potential to assist designers in making informed decisions about fabric selection and designs, as well as to provide the user with a way to communicate their fabric experiences to experts. It can also be used by designs and technology experts to get insights of fabric tactile and affective experiences in order to create future physical and digital tactile experiences. In summary, this study provides new insights into the temporal fabric tactile and affective experiences and demonstrates the potential of capturing and communicating such experiences between users and experts for future fabric experience design. Thank you for listening. This project is funded by both of the EU-funded Touchless AI project and the UKRI-funded Textile Circularity Centre. I am also grateful for the assistance and support provided by our colleagues from the Multisensory Device Group at UCL and the UCL Interaction Centre. Thank you.